Number 32. A ball is attached to the end of a string. It is swung in a vertical circle of a radius 0.33 meters. What is the minimum velocity that the ball must have in order to make it around the circle? So first we need to understand that when we're talking about the vertical circle, we have a ball on a string and it's going to be swinging around in a circle. The force that's going to be acting on the ball is going to be mg in the downward direction. So if we're going to be asked to find the velocity, we're going to be using the equation of our net force equaling mv squared divided by r. Now, our net force, what we know of our force is mg. So we're going to have mg equal to mv squared divided by r. Since we have m on both sides of the equation, we can cancel out m, and we're left with g equals we're left with g equals v squared divided by r. So that makes it a little simpler because we've already simplified our equation, and now we just have to continue to simplify it to get v by itself. So if we multiply both sides by r, we will be left with v squared equals gr. And if we square root both sides, we will then get v equals the square root of gr. So we now have our equation that we're able to plug into and solve and get our answer. You can see that the only thing that they supplied to us was the radius in the problem, and that's all that we'll need, because our radius is going to be 0.33 meters, and we know that g is our 9.8 meters per second squared, which is our gravity constant. So if we go back to v equals square root of gr, and we plug in our numbers, we have the square root of 9.8 meters per second squared multiplied by 0.33 meters, and we will end up with a velocity of 1.8 meters per second. In number 33, it says a ball is attached to the end of a string. It is swung in a vertical circle of a radius 2.5 meters. What is the minimum velocity that the ball must have in order to make it around the circle? So again, we need to understand what we're doing. So we have a ball that is being swung in a vertical circle, and again, we're going to have a downward force from our force of gravity. So again, if we start with our net force equaling mv squared over r, we're going to again substitute in our force of gravity for our net force equal to mv squared over r. So since we have m on both sides, we can cancel m out, and we can rewrite our equation as g equals v squared over r. If we multiply r on both sides, we will be left with v squared equals to gr. Again, we need to square root both sides to get rid of the square, and then we are left with v equals the square root of gr. In the problem, they tell us that our radius is 2.5 meters, and again, we know gravity is our 9.8 meters per second squared. So if we go back to our equation that we just derived, we can plug in our g of 9.8 meters per second squared and multiply that by our radius of 2.5 meters. And when we multiply and then square root, we will end up with a velocity of 4.95 meters per second.